Real YouTubers love math. Mr. C is bad teacher for putting this video up late. Hello, YouTube. Today we are going to talk about area of rectangles and parallelograms. So the cool thing is you already know how to do rectangles and squares area. And all we have to do is we just take our length times our width. So that's the long side times the short side. In a square, it's just side times side. And as we learned this year, we can use an exponent to show that as side squared, side times side. So it's actually really cool to see the square this way because this is actually how we're going to put our units at the end. So we do our length of 8, area equals length times width. And we do the length of 8 times the width of 6. And we end up getting an area of 48 somethings. I have to put a unit. And you guys learned years ago when you learned about area that it's square units. In this case, the unit is inches, so we're actually going to have inches squared. I actually want to show you something cool about this. You guys are used to seeing stuff denoted like this year. 7 times 7 could also be written as 7 squared. Well, look what we're doing here. We're doing, of course, length times width, but what if I just put the units there, inches and inches? If I did inches times inches, well, what would another way to write that be? It'd be inches squared. Guys, that's the math behind why do we show area of two-dimensional figures, such as squares and rectangles, as inches squared, because we are taking inches times inches. That's why. So when we label our units, we have to make sure we include that square units. Okay? It's talking about all the space that's inside. And we're taking inches times inches in this case, getting inches squared. So you guys know how to do the square. We would just take area, equals side squared. And the side in this case is 9. And this is just for squares. I could just do 9 times 9, but look, that's essentially what I'm going to do anyways. Okay, so the area equals length times width works for both rectangles and squares. The squares just has this other cool one of side squares that's just a little fancier, but it does the exact same thing. Okay, so our area for this one would be area equals 81 inches squared, because we're taking inches times inches once again. Okay? The other examples work the exact same way, so I'm just going to skip those to keep this video nice and short and sweet for you guys. Area of parallelograms is the next section. This is the new thing. So this is really, really cool. A parallelogram is essentially a rectangle that's been tilted over on its side. Okay? And the formula to find it is actually the same as what we used for the rectangle. However, we have to use a special way to find the height. The base is the same, okay? The way we find the base is the same. We have to use from the corner down to the base as the height. Well, why is that? Well, if I take this to make that a straight side, and I look at this little triangle, if I take this triangle and I move it over here, look what happens. Didn't I just make an entire rectangle? So what would I use in an area of this situation? Well, I'd use the base, which is still the same. This little section that got cut up over here is the same section that's here. So the base is the same. That doesn't change. But the height is not what you think it is. It's not this tilted side. It's the one that goes straight up and down. It's right here. This is the height that I have to use. It's not the tilted side. The tilted side is going to be too long. We don't want that. No, 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 not the tilted side. Do not use that one. It's there to trick you. Okay? In this example right here, example number 6, I would count my units on the bottom. 1, 2, 3, 4, 5, 6 units. And then going up, I have 1, 2, 3, 4, 5, 6, 7, 8 units going up. So to find that, I do area equals base times height. So the base is 6. The height, again, it is not the slanted part. It's the one that goes straight up and down. 8 units. 6 times 8 is going to give me 48. And just like I did before, the area is going to be 48. Well, I don't have an official unit of measurement, so I just have to use this general one, units, and then I square it. Okay? That's it. That's everything you need to know. I do want to go over just maybe one more perhaps with you, just so you know what to do. So let's take a look at this guy right here. It's given us a whole bunch of information, but area equals base times height of this parallelogram. The base in this case is 4. Now the height is the one that's tricky. Remember, Mr. C said do not use the slanty side. You've got to use the one that goes straight up and down. Well, the one that goes straight up and down is this guy, 16. That's the one I want to use. The tilted one, that's too long. Okay? That's way too long. We cannot use that one. So we've got to do just 4 times 16, and that is going to leave me with 64 meters squared for the area. Okay? This one, number 4, we're just working backwards a little bit. It gave us the area, which is 45, and it says find the missing piece. So it gave us the area, and we have the base, which is 9, times the height, which we don't know. And guys, look, it's just turned into a fancy equation. Solve for h. What should I do? Well, I'll divide both sides by 9. And when I do that, it gets rid of these two bozos, the 9 and the 9. And we're left with just h on the right. And we do 45 divided by 9, and that's going to equal 5. So I do need to be specific, however. It's going to be the height is 5 inches. Mr. C, but wait, you have to put square. No. I'm looking for the piece. I'm going backwards. So this piece right here should be 5 inches. When I take 5 times 9 to find the area, then I would also do inches times inches to get inches squared. It gave us that information right here. Okay, it gave us the answer. We had to go back and find the piece. Okay, guys, that's everything you really need to know about parallelograms. I hope this video is very helpful, and I'll see you on the next one. Peace out.